Welcome to trigonometric functions of multiple angles. Using the trigonometric function formulae of sum of angles and difference of angles that we have already derived, let us now find the trigonometric functions of multiple angles. First of all, double of an angle. We need to express various trigonometric functions of a double of an angle in terms of the original angle given to us, the theta. First of all, for sine 2 theta, we put A is equal to theta and B is equal to theta in the first formula. That is sine A plus B equal to sine A cos B plus cos A sine B. A equal to theta and B equal to theta, we put in this. Then the equation changes to sine theta plus theta equal to sine theta cos theta plus cos theta sine theta. We have just replaced A and B by theta throughout. So the LHS is now sine theta plus theta, which is sine 2 theta. RHS is sine theta cos theta, again sine theta cos theta, so twice of sine theta cos theta. This is the first formula. Sine 2 theta is equal to 2 sine theta cos theta. Now, to find cos 2 theta formula, we need to put the same in the second formula, cos A plus B. Cos A plus B is cos A cos B minus sine A sine B. So while replacing A and B both by theta, we'll end up in this equation. Cos A plus B becomes cos theta plus theta, and cos theta minus sine theta by replacing A and B to theta. So if you go ahead, the RHS is now cos square theta minus sine square theta. That is equal to cos of 2 theta. This is one of the formulae for cos 2 theta. This formula can be rewritten in terms of sine theta alone by using the well-known identity cos square theta is 1 minus sine square theta. By simplifying this, RHS becomes 1 minus twice of sine square theta. This also is used as another formula for cos 2 theta. Sometimes we change the sine square theta in terms of cos square theta using the same identity sine square theta plus cos square theta equal to 1. And by simplifying, we get 1 minus 2 plus 2 cos square theta, and on simplification we reach at cos 2 theta is 2 cos square theta minus 1 also. Hence, we have cos 2 theta written in terms of in three forms. One is cos square theta minus sine square theta, 2 cos square theta minus 1, 1 minus 2 sine square theta. Three formulae for cos 2 theta. Lastly, for sine 2 theta, put A equal to theta and B equal to theta in tan A plus B formula. That gives us tan 2 theta on the LHS. RHS is tan theta plus tan theta upon 1 minus tan theta as A and B both are theta. So the LHS become tan 2 theta is equal to twice of tan theta. Tan theta plus tan theta is 2 tan theta upon 1 minus tan theta into tan theta is tan square theta. Here we are with the third formula. So we got another set of formulae, multiple angles. 2 theta, double of angle theta, its trigonometric ratios, trigonometric function values are written in terms of the angle theta, the original angle theta. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta, either of these three formulae, depends on the occasion. We use any of these three for cos 2 theta. And tan 2 theta is 2 tan theta upon 1 minus tan square theta. Now let's see how we use these multiple angle formulas. First of all, sin 2 theta is equal to 2 sin theta cos theta, the first one. In case we want to find out sin 120 degrees, as we know, 120 degrees cannot be drawn as one angle of a right triangle. It's an obtuse angle. So, 120 degrees terminal side is in the second quadrant. Sine 120 degrees, sine of an angle in the second quadrant should be positive, as we have learned earlier. But here what we do is treat 120 as twice of 60. Of course, twice of 60 is 120. And now treat it as sine 2 theta, where theta is 60 degree, and apply the formula 2 sin theta cos theta. That gives us the step 2 sin 60 cos 60. Theta is 60. Giving the values of sin 60 and cos 60, which we are familiar with, 2 into root 3 by 2 into half. Simplify further, it gives us root 3 by 2. So we have sine 120 degree equal to root 3 by 2. It's a positive value as we decide. Now, sometimes we get to simplify this kind of function sine 10a using this formula. Treat 10a as twice of 5a. And applying the formula we get 2 sine 5a cos 5a. This kind of simplification is required for further questions in this chapter. So I'm just making you familiar with this kind of little simplifications. In case you have sine 7a, it can be rewritten as 2 into 7a by 2. Theta is 7a by 2. 7a by 2 into 2 is 7a itself. It is to use sine 2 theta. Theta is 7a by 2. So it can be rewritten as 2 sin a by 2 cos 7a by 2. Also sometimes sin x, simple, looking very simple. But we need to write this function in its half angle. Why half angle? Yes. If you want to treat it as 2 theta, it should be 2 into x by 2. 2 into theta, 2 into x by 2 is x itself. So treat x by 2 as theta and apply this formula. So we can write it as 2 sin x by 2 cos x by 2. Now, let's see the second formula, cos 2 theta's application. Cos 2 theta has three options. Either of these could be used. First of all, I'm calculating cos 120 degrees. 120 degrees again, as we noticed already, it is having this terminal side in the second quadrant. And cosine of such angle should be negative. Let's see whether we will get a negative answer. We will first apply the formula. 120 written as twice of 60 and treat 60 as the theta and apply cos square 60 minus sin square 60. Cos 60 is half, sin 60 is root 3 by 2. So half square minus root 3 by 2 whole square. On simplification it is 1 by 4 minus 3 by 4. That is equal to minus 2 by 4, which is minus half. Look, we got the value cos 120, a negative value. It was necessary, it was evident, as 120 degrees terminal side falls in the second quadrant and we got the negative value automatically. Again, cos 10a, rewriting it as twice of 5a, we may write it as cos square 5a minus sin square 5a, or cos 7a can be written as cos twice of 7a by 2, which will lead you to cos square 7a by 2 minus sin square 7a by 2, or even cos x can be rewritten as cos square x by 2 minus sin square x by 2. These kind of simplifications will help you in simplifying big trigonometric equations later.